In this video, we will see how Rafay helps streamline Amazon EKS operations for 5G edge applications using AWS Wavelength. Let us start off with a background on the problem. Applications are typically deployed in a specific data center and serve users in all regions. However, for modern smartphone-based applications, the ensuing latency can result in a significant impact to user experience. For example, assume our application is deployed in AWS's US East region in Northern Virginia. End users of the application on their smartphones are primarily clustered in heavily populated metro areas. For example, millions of users in Miami and Houston will suffer from a degraded user experience just because of network latency to US East. A wavelength zone is in a carrier's physical location, example, Verizon. This is where the wavelength infrastructure is deployed. A wavelength zone is a logical extension of the AWS region, and it is managed by the control plane in the region. Amazon EKS with worker nodes in AWS wavelength zones allow application owners to deploy and operate their latency-sensitive applications in the same metro location as the user. Rafay has collaborated with AWS to develop a deep technical integration between Amazon EKS and AWS Wavelength. The integration enables customers to solve two foundational requirements. The first one is, how do I provision, manage, and operate an Amazon EKS cluster with wavelength node groups? The second challenge is, how do I deploy and operate a copy of my application in every wavelength zone? Now let us see a demo of this in action. Let us first use Rafay to quickly and easily provision an Amazon EKS cluster in the US East 1 region. Next, let us add worker nodes in the Atlanta wavelength zone to the cluster. Once this is successful, notice that the EKS cluster has a visual indicator showing the administrator that the cluster is enabled for wavelength. Now let us look at what a worker node in a wavelength zone looks like. Notice that Rafay provides the administrator a visual indication that the node is in region or in a wavelength zone. Also notice that the wavelength nodes have special labels indicating which wavelength zone they are operating in. It's also important to notice that the nodes are assigned a carrier IP. The carrier IP address is attached to the worker node in the wavelength zone. Subscribers of the telco, the carrier, will access applications attached to the carrier IP. In the next step, let us deploy our latency-sensitive workload to the wavelength zone. We have configured a workload template based on an Nginx application. We have a GitOps pipeline based on the Nginx workload template, but notice there's a specialized label for the workload placement selector. Specifically, we have selected a node group selector called alpha.rafay.io, which ensures that the controller, which runs a control loop for the placement policy, ensures that a copy of the Nginx workload is automatically deployed to every attached Wavelength Zone in the EKS cluster. So with Rafay, you can now easily and quickly provision and manage and operate Amazon EKS clusters with wavelength zones and deliver a great experience for your users. Thank you.